Hi guys, welcome back to LGF. So today I have to discuss about the first order system, second order system, and the system output for the various input functions like delta function or unit impulse function, unit step function, unit ramp function, and for the parabola function, right? In the lecture 7 we discuss about the time response, the total response of the system comprised by the transient response plus steady state response. So the total response is nothing but transient response plus steady state response, correct? So this is CT for CT, this is the total response of the system. This is transient plus CT of steady state, correct? So for the transient response we have seen this is the response at t equal to infinity it will become 0. At t equal to infinity this response value is 0 because at t equal to infinity or the time, very large time, will get the steady state response. This time this time response, steady state time response, will get at t equal to infinity. So if your response becomes 0 at t equal to infinity, definitely will be having exponential terms, correct? And if I'll talk about the steady state response, the steady state response is not going to die at t equal to infinity, so it will be having some constant terms as well as some oscillatory parts, correct, like sin t, cos t, whatever it is. Okay, so the system response, if contain the exponential terms, means definitely it's going to introduce the transient response. It will introduce the transient response. Okay, and if system response or the transfer function contain or the output contain constant term or the sinusoidal or oscillatory terms, definitely these things belongs to the steady state response, correct? Now we have seen if in the S domain, I'm talking about if your poles are negative real part or in the left hand side of the S plane. This is the S plane, and to this S plane I have poles in the, see, this is the left hand side. So definitely this pole is going to provide me the exponential term, means the transient response, correct? And if you have the poles at imaginary axis like this, they are going to provide you steady state response, okay, because these poles are oscillatory in the nature and they'll provide the steady state response. I hope it's clear to you. Now today we'll discuss the first order system. Okay, let me clear this part, then we'll switch to that. So today's topic is time response of first order system. We'll see the first order system. Time response is okay, that we are going to deal with the time response like transient response and steady state response. But what is the first order system? First order system, this is the block diagram representation of the first order system, in which the forward path transfer function is given by 1 by st. This is the open loop transfer function of the first order system. If you will find out, it's very easy to find out the closed loop transfer function. The closed loop transfer function, that is the transfer function of the first order system, will be 1 divided by st divided by 1 plus st. Though this is the unity feedback, see, this is the unity feedback, means the value of h is 1 over here. So this is multiplied with 1. Finally what you will get st plus 1, correct? So this is the transfer function of the first order system. Now the question is why I'm saying this. This is the first and the term is order associated with this. Okay, how will check this, whether this is the first order system or this is the second order system? how we'll check this? Friends, whenever there are two things you'll encounter with, number one is order, no problem, and another one is type. Okay, if in the question you will get transfer function, let's take for the first order system s tau plus 1. Okay, now if the question is what is the order of the system and what is the type of the system, O for the order I'm taking over here and T for the type I'm taking over here, my question is what is the order and what is the type of the system. Okay, so first I'll tell you what is the order and what is the type. So order is, suppose you have transfer function s tau plus 1, the highest order, this is the highest power of the a's in the denominator is nothing but the order. So here order is 1, highest power. Instead of this, suppose you have s tau plus 3 also. If you multiply this equation, overall you get s square term. So maximum power of the a's will be order of the equation or the transfer function. So here order will be 2, correct? And what about the type? Type is the, the maximum power of s at s equal to 0 or at the origin. Okay, type is, if you have s to the power n over here, so this n I call the type. This n is the called type. This system is the type n system. Okay, so the poles which are located at the origin provides the type of system. Is it correct? So suppose you have a transfer function like, so for this now I'll take the transfer function s square s plus 1. Suppose someone will ask what is the order of the system and what is the type of the system. So order over here will be 3 and type over here will be 2. So type is nothing but the number of poles at origin. If this is S plane, I'm talking about the number of poles over here. Okay, and total number of poles in the denominator will provide the order. Now one very important point, mostly students will do mistake over here. This order and type always given for the open loop transfer function of any system. The order and type always given for the open loop transfer function of any system. Very important, please note down it. If you'll get in the GATE examination, the transfer function will be given like this. They'll say this is the closed loop transfer function given for some order of the system. Definitely this is the first order system, but they will give you this is the closed loop transfer function of some system. What is the order and what is the type? What is the type of the system? So please do not give the answer on the basis of closed loop transfer function. If you will give the answer that order is 1, if you'll observe this transfer function, definitely you'll say that the order is 1 and the type is 0. Why type is 0? Because I don't have s to the power n terms, means the poles at origin I don't have. That's why I'll give t equal to 0. This will wrong. You will lose your 0.33 marks in the GATE exam. Why? Because here this is the, if they are asking for the order and the type, you will always look to the open loop transfer function. Is it okay? So we discussed earlier, if you have given with the closed loop transfer function, how to find the open loop transfer function. I think you remember this formula, but let's talk about this. The closed loop transfer function we calculated for the first order system. For the first order system, the open loop transfer function is given over here. So this is the open loop transfer function, correct? Open loop transfer function of the first order is nothing but 1 by st. So based on this, we'll take this as a reference and we'll answer this question. Here the type of the system is 1 and the order of the system is 1. That's why I'm saying this first order system. So please note down, this is the very important formula or very important point, that always type and order defined for the open loop system only. Correct? Now the question is, in the examination they'll ask the question, in that they'll define the closed, or they'll give you the closed loop transfer function. So you will find first the open loop transfer function, then you will conclude it, right? So the point is, types and order, please note down this point. Types and order of the closed loop control system is defined for the open loop transfer function system of the unity feedback. And this should be unity feedback, very very important. Two things should be there. You have to consider the open loop transfer function, and the entire closed loop system should be having unity feedback. Correct? Now over here I'll consider one practical example of the first order system, and that is the RC. Wait a minute. RC circuit. RC circuit is one of the examples of first order circuit. So the circuit is like this. R and C, they are connected like this, R and C. Okay, so this circuit is going to provide me the first order system. I'll find out the transfer function. For the transfer function, let's take the input is Vi, I applied over here. I'm checking output over here across the capacitor. The transfer function of this circuit will be V0 by VIS. Is it okay? The transfer function or the value of V0, please find out this. So first, this is given in the time domain, will convert into the frequency domain or S domain. You people know and studied in the network theory, R will be as it is. This C will become 1 by CS. I'm sorry. And over here the input stage, I'll call it now VIS. The output stage, I will call it, this one is V0S. Now transfer function will be definitely the output, the Laplace function of the output divided by input is nothing but the transfer function of this first order circuit. So now voltage across this, can you apply the voltage division rule? It will be 1 by CS multiply with VI divided by R plus 1 by CS. This VI already you consider in over here, so I'll remove. Okay. So when you will calculate this or solve this, you will get 1 divided by RCS plus 1. So this is the transfer function for this circuit we are getting. The transfer function for this circuit is RCF plus 1. Correct? So first order circuit, there is no problem. For the closed loop control system also we can say the order, or we can judge the order. Sorry, this is as given over here, right? This is the open loop transfer function of the first order system. Here the order is 1. If you find the closed loop transfer function for this of this entire system, you get order 1. So here the number of S terms is always provide the order of the system, or I can say the number of memory element in the circuit provides the order of the circuit. If instead of this C you are having L also in the circuit, you have RLC circuit, so you have 2 memory elements or energy storing elements. So here this system will be second order system. If you have RL circuit or if you have RC circuit, it is first order circuit. Correct, friends? So for the RC you have transfer function like this. Okay, so now standard, if you compare the transfer function of the first order with the standard generalized formula, it was 1 plus ST we have seen for this circuit. So here this T is RC, so this T is RC. T is nothing but the time or see this T is the time constant. So for the RC circuit, so the time constant is T is nothing but RC. Okay, you already seen this in the network theory, correct? Now instead of RC, now if you have RL, so I'll take RL like this. This is inductor over here, L. Here I'm taking resistor R. Across R, I'll take the output like this. V1, if I'll convert into the Laplace domain, this will become Ls. Here it is V0 S. In this case, if you'll find out, let me change the color. Wait. So in this case, if you'll find out V0 S by VIS, what you will get is 1 upon 1 plus S tau, and here you'll get 1 plus S L by R. So the tau or the time constant in the case of RL circuit will be L by R, and the same thing for the RC circuit will be RC. So this is the time constant, one for RL circuit and one for RC circuit. Very important. Okay, so I hope this is clear to you. Okay, now we'll see the impulse response of the first order system, what it means. Friends, we have seen the transfer function of the open loop, or sorry, first order system, right? We have seen first order system, first order system. Now this heading implies that impulse response of the first order system means to this system I'm going to provide impulse. Okay, I'm going to provide impulse. I'll take output CT. So I'll discuss about this. After the impulse, I'll apply the unit step to it. I'll get output C1T. We'll discuss about this also. Then I'll apply the unit ramp to the same system, first order system. We'll get CRT, whatever it is. Then I'll provide the parabola input to this, and I'll get some output over here. So we are going to discuss about this 4 input output relationships. So the first one is impulse response. So what is the transfer function formula we got from the previous circuit? CS by RS is nothing but 1 plus S tau. Is it okay, friends? So now we are going to apply input RT is nothing but del T. So what will be the RS? You need the Laplace function of the input. So definitely it will be 1. Okay, because Laplace transform of del T is nothing but 1. Okay, so here RS is 1, so your output CS is nothing but 1 plus S tau. Okay, so please take the Laplace inverse. You will get the time response or the output in terms of time parameter. So what is the L inverse of this? You will take over here, you will take, let's take tau out. It is tau. Over here S plus 1 by tau. Now we'll take the L inverse of this circuit. L inverse. Here you will get CS. Sorry, this is already S, right? So now we'll take the L inverse. So you will get in the time domain. So in the time domain it will be 1 by tau e to the power minus 1 by tau t. Correct. So this is the output for impulse response. For the impulse response, this is the output. Now if you observe this very carefully, this response, you are getting CT equal to 1 by tau e to the power minus 1 by tau t. Okay, it contains only exponential terms. Is there any constant or oscillatory term? No. So this is completely transient behavior. Means in the impulse response you will not get any steady state response. You will get only transient response. Correct? Now if I'll talk about the steady state error. For this, if I'll talk about the steady state error for impulse response. Okay. Will I get any steady state error? Why? What I'm asking is, see, for the particular first order system you applied the input, your transient response you'll get over here at the output. If you'll apply the impulse response, you'll get at the output the transient behavior, complete transient behavior. And someone is asking find out the steady state error. And actually what is the error for any system? Error for any system is RT minus CT. Means what you applied at the input, what you get at the output. The difference of these two terms is nothing but the error. Right? Steady state error is nothing but the error at t equal to infinity. Steady state error. So when t tends to infinity, the error is nothing but the steady state error. Okay. So tell me, if you are having del t your function, del t is only defined at t equal to 0. At this infinity, the function is not defined. Okay, the del function is only at t equal to 0. Okay, at t equal to infinity, your function, your input is not exist. So can you calculate error for this? If you calculate error for this, you have to consider the input at t equal to infinity. R infinity minus C infinity. Do you have R infinity? R infinity means the input impulse function at t equal to infinity. The impulse function is not defined at t equal to infinity. So you don't have this. So you can't find the steady state error for impulse. Correct? So in other words, I can say the steady state error are not defined for the impulse input because there is no input present at t equal to infinity. So hence we can not compare output with the inputs at t equal to infinity. Correct? So I hope it's clear to you. Okay. So finally, conclusion for the impulse response of the first order system is the output CT you'll get 1 by tau e to the power minus t by tau. This is your response. Correct? Okay. Now one more thing, the steady state error is not defined for impulse response. So only two things are here. Correct? Now we'll switch to the unit step response of the first order system. Unit step response of the first order system. Again, the transfer function of the first order system is 1 divided by 1 plus s tau. Correct? Rs, your input now, RT is the unit step. So the Rs will be 1 by s. The Laplace transform of unit step is 1 by s. You know about this. So Cs you will get 1 by s, 1 plus s tau. Am I right? Now please take the partial fraction of these two terms. Okay, this will be a divided by s plus b divided by 1 plus s tau. Let's find the value of a. The value of a will be 1 divided by 1 plus you'll put the value 0 over here. So definitely you'll get 0. It is s plus 1 plus s tau. Here you'll put s equal to, let me take 1. S equal to, you'll put over here minus 1 by tau. So finally you get 1 by s minus tau 1 plus s tau. Okay. So this is the partial fraction of this term. Correct? So this is your CS also. Okay, perfectly fine. Now I'll take the inverse of this. So you'll take the inverse of this, you'll get CT 1 by S is nothing but your UT, that is 1 itself. Okay, let's take like this. Whatever input you applied, you are getting at the over here output. Now the subtraction part is tau over here, and when you will take tau out, this tau will cancel, finally get e to the power minus t by tau. So your response is nothing but 1 minus e to the power minus t by tau, and this is ut, correct? So this is your response. Now this part is the constant, and we discussed the constant term is nothing but the steady state response. Is it okay? This is the transient response. Okay, in the starting we discussed about this. The exponential term is nothing but the transient, and the constant or oscillatory terms is nothing but the steady state response. So now can we calculate the error for unit step? Yes, we can calculate. Why? Because unit step is defined at t equal to infinity also. This is the unit step function ut. Okay, at t equal to infinity also its value is 1, like this. So the function is present at t equal to infinity. But in the case of impulse, we don't have any function, input function at t equal to infinity. So we cannot find that the steady state error for the impulse, but for the unit step we can do that. Correct? So your ET will be input you applied 1 or UT minus your response CT. What you get? 1 minus e to the power minus t by tau. So this will cancel to this, and you will get e to the power minus t by tau. This will be your error. E to the power minus t by tau will be your error. Correct? And if you'll observe this, what you are getting this. How the response will be? For this your response will be like, see, I'm drawing the CT. This is 1 minus e to the power minus t by tau. So this response will be, let me change the color. This response will be like this. Okay, at t equal to infinity it will attain the value of 1, because if in this formula, let me take over here, CT is nothing but 1 minus e to the power minus t by tau. At t equal to infinity this term will be 0, so output you will get is 1. So at t equal to infinity it will touch to this value. Correct? So this is your output for the unit step. Okay, now for the unit ramp and for the unit parabola, directly I'll write the output. You can calculate the same thing. Okay, so for the unit ramp, you will get output CT is nothing but t minus tau 1 minus e to the power minus t by tau. This is the response for unit ramp. Correct? Let me correct myself. I did something wrong over here. This is not CT. This is ET I drawn over here. This is for error. E to the power minus t by tau graph is like this. Correct? No. I'm extremely sorry for this. This is correct. This is for CT. I forget to wait a minute. I'll draw this one error also. Okay. So the error diagram will be like this. This is the error. This output is for the error, and this is your overall output of the system CT. Okay. So this is the unit ramp. For the unit ramp, the CT is nothing but this. If you will calculate the steady state error or simply the error, you will get in this case it's equal to tau, exactly equal to tau. And if you'll find the same thing for the parabola, the function CT or the output you will get is at square by 2 plus bt plus C plus dE minus T by tau. So this is the transient term, and this all are the related to the system response, correct? So this is all about the, if the first order system, you'll take the first order system and you will give the input like unit impulse, unit step, unit ramp and parabola. You'll get different outputs. We have seen all outputs, and with this we have seen the errors also, correct? So let's come to this now. This is the summary of this, the input, output and error. The input, if you have unit impulse, you will get Ct is 1 by tau, e to the power minus t by tau. Error is not defined, and this we are discussing for the first order system. First order system, correct? For the unit step, you will get 1 minus e to the power minus t by tau. The error is nothing but e to the power minus t by tau. And for this, you will get exact tau. This is steady state error I have given over here. Steady state error, but simply if you will find out the error, you will subtract this term from the t. So you will get this tau 1 minus e to the power minus t by tau. This is your ET for unit ramp, and this tau is the unit. See, this is the steady state error, okay? Exact error is this one. For the parabola input, you will get output this, and this will be your error, correct? So friends, this is all about this class. In the next lecture, we'll see the second order system. Second order system, okay, and we'll switch to the some problems based on first order and second order system response, correct? So friends, for the new updates you can subscribe LGF, and for the doubt solving you can find us on the Facebook. We'll meet in the next lecture. Till then, take care and bye.